In February, we're going to have a community lightning talks. Matt is going to talk what he learned about since the last time he was with us. And Kuds also, he wrote a 5 days program for African music. He is revamping that, and he's going to share what he's up to now. And other volunteers are welcome as well. You'll find more info if you click on the links behind these photos after the meetup. I'll share with you about us, those who are here for the first time. So we started as function as a service developer, playing like kids with Lego pieces, gluing things together, and that enabled us to develop products and MVPs faster and help startups most of the time, because big companies were closed at the time for us, and and also we became friends with front-end developers, voice-first developers. So when you look at all these three segments, in the center there is agility. So we are starting to define serverless as a new agile and a new mindset. So more about the mindset. Just last week, I was watching the video by Sam Newman. He's the author of the book Building Microservices, and how now he's promoting the new book Monolith to Microservices, and he's questioning the industry, why we are focusing more on the tooling rather than on what tools allow us to do, how to help businesses. So that aligns with my view. I think that we are more often like car mechanics, enjoying to pimp up the cars instead of letting business ride them and driving the business forward and taking them places. So I was excited to see somebody with similar opinion. Also, like I love Ben Coy's thinking, and one of the sayings he has, that serverless really is the mindset that can be applied to any tech stack, even on your on-prem data center. So why? Because it's about direction, not about destination. And so what we are not about is about dogma and avoiding it. And I took this slide from Simon Wortley's presentation on serverless. The link is available. You're gonna laugh your head off and learn a few things. So I encourage you to watch that. And Ben Talks is also here from Boston about the serverless mindset. So that brings me more to mindset and compassion. Like yes, Kelsey is a guru, but I was drawn to him mostly for his compassion. First off, that was the first reason when I discovered you in 2018, when you were talking that people should learn respect. And then ever since, I always enjoy following your tweets. But then when this COVID thing happened, and like a crisis in states and around the world, most of the leaders we had and people around were pretending as nothing happened. I call this ostrich headed descent approach. And you spoke up. And we are kind of trying to change the world, but we must care about the people around us and those whose right has been taken away. So I'm really honored, and I feel lucky to be able to talk to you, Kelsey. And we invited you to enlighten us a little bit about the Cloud Run and where serverless meets containers, because there is lots of talks about one versus the other, but I feel two technologies are converging rather than diverging. And then the cloud next happened, just recently finished. So maybe a couple words on that, and it's going to be Q&A interactive session as we spoke. So that would be my part. Kelsey, take it away. Thank you so much for being with us.
That was pretty dope, by the way. So yeah, so we're talking about serverless a little bit, and I think last year, maybe even the year before, when I saw this serverless thing, I was like, okay, what are people actually talking about? Is this actually something super new? My career spans about maybe 15, 16 years, and I've just seen a lot of things come full circle. We give new names to existing things, and then people get super hyped up and lose their minds, like, oh my God, look at this thing. And then it's like, damn, now we got to spend the next 2 years like reminding people that this ain't as new as you want, slow down. It's just kind of rethinking this thing with another API, and that's okay. So we got to de-hype it. So when I jumped into Lambda, actually, even though I work at Google Cloud, I still touched technologies from the other providers. And the thing that was really interesting about Lambda, number one, was the API gateway. If you're building APIs, this is kind of something you need, regardless if you use Nginx, HA Proxy, Apigee, but just having something there out of the box. And the thing that blew my mind about Lambda was just having native service discovery be built in instead of something people go and configure out of band, right? So then if you throw a function behind it, it seems to all just make sense for what most people were building when it came to 12 factors. So it was like a one-up on Heroku. It was a one-up on Cloud Foundry. It just said, let's take all this even more out of the app and only leave the one or two handlers that I need. So I actually started contributing to Cloud Functions internally at Google. So of course, if you've never seen Cloud Functions, it's basically like similar functions as a service. I'm going to share my screen just a little bit here. I'm not going to do a presentation deeply, but I just want to click around for some of the stuff that I'm talking about. So when people said we want serverless, the whole industry, every cloud provider is like, oh my God, we need functions as a service. Like, why? I don't know, because that's serverless and people want that. So we got to have one too, right? So everyone went crazy and everyone started building their serverless platforms, right? And when you look at these things, they're all pretty straightforward. You have some function signature you implement. Ideally, you'll have some source code that you share. I'm trying to actually find this. I'm going to do some of this live. So I'm going to download this zip file and I'm going to put it on my Linux server here. So this is the source code from this particular app. And the idea here, I'm just going to show you all what I'm doing here. Before we actually had real function support, we actually had to do a couple of hacks in GCP. So let's do unzip function source. And basically, when I started actually working with functions, one thing that was pretty weird was like, how should our function look? And should we just kind of copy the Lambda world? But when I started writing like production level functions, especially in a type language like Golang, it turns out my code was just about as long in terms of, developer productivity. I'm still implementing, this is Golang, by the way. I'm still implementing this very simple function signature. In this case, it's just an HTTP function signature that takes the request, takes the response writer. This is how you write HTTP handlers in Go. And we came up with this little convention called F. Of course, this is configurable today in cloud functions. But ideally, you could write code that looks something like this and deploy to cloud functions, and it will feel like Lambda. I can map some events. I can have events flow to it. But when we looked at this, I'm like, there's so many limitations here. Number one, what if I need to connect to a database and all I have is this one entry point? Then what we start seeing people do is creating these like initialization functions and doing all of this stuff because they don't have function main. Even when you look at Lambda, they have a function main where you import some Lambda things, and I get it. Lambda doesn't host the server. There's a client that connects to some other endpoint. Either way, the style of writing code becomes a challenge when you try to limit yourself to functions. So in the Google Cloud case, we thought about this and said, look, we can always have functions if people think that they want to write functions, and they can make them big or small as they want. So I had a new project to work. Even though I worked on Cloud Functions Go support, I had this little service that I wanted to build called Badger. And all it does is say, if you're using Google Cloud Build, which is our cloud native CI/CD tool for building and running kind of CI/CD style projects, I just needed something that can do status pages. But the problem is that's not a native feature of Google Cloud Build. So I was like, well, what if I just wrote a simple app that will let you print your badge status? So for example, if you deploy this little service, you can actually embed a URL and get back the status from that particular thing. So basically, if you call the endpoint where this is hosted with these parameters, you'll get back one of these build badges, right? Very simple service. And I could have done this as a function, but I decided to do something else. I decided to do this as a container, right? And this is where most of the people in the service community start freaking out. Oh my God, he said container. Containers mean servers, and servers mean Docker, and Docker means complexity. And I'm sitting there, it's like, why are people arguing between zip files and tarballs, right? Because a container image is a tarball with metadata, and the Lambda kind of package is typically a zip file, and there's probably some metadata in it too. And if people are really getting religious about this particular thing. And so when I wrote this code, I didn't want any restrictions for local testing. It was less about lock-in, and it was more about just writing native code in the style that just works on my laptop, right? So in this case, this is just normal code that I could compile on my laptop, run it, test it, hit the endpoint, see if it all works, and just write normal code like I would normally do, right? So there's nothing really specific to the cloud provider here, even though I have a little wrapper called run, just so I don't have to think about certain logging and certain HTTP handlers. But for the most part, this is just code that runs on my laptop. And I also understand Docker, right? So when I package my app, I'm going to show you this Docker file. And for a lot of people that freak out about Docker, it doesn't need to be too complex, right? If you look at this, all I'm saying is build my source code. I need some SSL certificates from a very small image because I need to be able to call other services. then I just copy my static binary to this second image and I flatten it. So if you look at this image is the same size roughly as my binary. All right, there's no operating system in there. There's no Red Hat. There's no Debian. There's nothing to patch. All I have is the Go runtime, right? Now, this will be different if I was doing something like Node.js, where I do need a base layer. So in all transparency, everything isn't going to be a static binary. But for my world, I write everything in Go. So I usually only have one binary. In this case, some SSL search so I can call some Google endpoints and verify their identity. And then I just started up this way. I found this way easier to reason about than random function signatures, right? Something I could test locally. And when I go to deploy this thing, a lot of people think that's a complex thing. If you look at the deployment process, for example, if we go to Badger, like how would I deploy this? Well, I always, when I'm writing my kind of services this way, I usually have a simple script. I could use Terraform. I could use something else. But most of my projects ends up being about this long. How much memory do I want? Make this a little bit bigger. How much memory do I want? I want to use fully managed, so no Kubernetes clusters, no Docker. Actually, our internal implementation doesn't even run on Kubernetes nor Docker. It actually runs on internal infrastructure, the same infrastructure that runs your VMs. We actually run your containers side by side. I give it the service account. I set up my authentication policy, and I just point it to the image that I wanted to run, and I pick the region. And then I get back a URL. So in terms of developer productivity, I found this as convenient as Lambda, but I can also do things like concurrency. I can have, since I'm writing in Golang, I can actually have multiple requests hitting this from a single instance. We also have this thing called minimum instances. So instead of scaling down to 0, maybe you have a large startup cost, like I got to connect to a database or cache some stuff. The nice thing is I can add another flag here called minimum instances equals 1, and it will keep an idle instance around for performance, and then of course scale up as more requests go over my 80 concurrency. So this kind of flexibility let people, again, not manage servers and just thinking on managed compute. And even with this, whether you're using Cloud Functions or you're using Cloud Run, you're still going to get all the same kind of functionality in terms of being able to use managed services. And the last thing I want to mention here before we jump into Q&A is that we built App Engine about 10 years ago, right? You know, by today's terms, people will consider it serverless because all you could use was managed services. And there was no concept of containers. You gave it its source code and you went from there. But over time, we decided that we want to break up our managed services into individual components. So for example, events can be routed to functions or containers or VMs or Kubernetes. Things like databases can also be routed or can be leveraged by any platform. So maybe more of that modern a la carte approach. I don't know why this is still spinning, but it'll eventually come up. So that's been kind of our approach here. It's like, let's reuse containers because we think it gives the best developer contract. It's portable. I can take my Badger service and run it on a VM. I can run it on my laptop, and I can run it in Kubernetes largely unmodified. So that's the philosophy behind our serverless products, is that we think serverless compute is a good thing for a managed level. But then you can use any managed service you want if you want the full serverless mindset. And if you want to, you can also route events to it using something like PubSub or our native eventing layer. But to me, serverless is like this very small part of the broader equation here. A lot of people are like, oh, I'm just going to do serverless and build an entire business. It's like, I don't know about that. There are actually so many other use cases that a function or even a container doesn't address. Like, for example, if you're in like the insurance industry, there's third-party software that you didn't build or write that will never be hosted in one of these platforms for now. So you're going to probably still need a VM, still need some traditional infrastructure. I was actually working with one of my large clients, and they use this geo analysis tool called Esri. It runs on Windows, and it's one of the best packages in the world. Porting that to a serverless stack is just not going to be worth anyone's time in the short term. So the reality is most people will have a mix of infrastructure components, but I love having serverless as an option. I'm going to stop there. We're going to open up the floor to any questions you want. I'm going to try to answer them as authentically as I can. If I can show it to you, I will. But I'm just going to kind of give you some insight that we don't typically get to do in YouTube or a conference.
Mm-hmm. Thank you. Thank you. Who's going to start first? I can tell you what opened my mind to Cloud Run. last real meetup that we had was about Zappa framework. And we had talented developer from Shopify kind of finding the apartment prices. And he went through a hard time setting up the environment serverlessly. And then the Zappa is unsupported framework. And then there is like, if you do monoliths in service, you're getting criticized. And he provided such a value with a framework like Cloud Run, you would be able to focus on the business value and just write the code the way you want. So that was one reason. Over 2 years and more, we're running meetups. I'm hearing developers complain how hard it is to switch the mindset as well to event-driven programming. So just getting in the cloud as a first step would be awesome, either way or another, and then they can benefit from being cloud native. So that was my thinking.
Yeah, so you got to remember too, it's not really about a mindset change, because 15 years ago, everything was event-based when I worked in the enterprise. We called them enterprise service bus, right? And then everyone, oh my God, you send a message and the message goes over here, and then you wrote just the handler. I used to write Java applications where I used to implement one method called onMessage. And then the bus would actually invoke your particular war file or ear file that implement this particular thing. This is not about a change of thinking. This is literally saying the framework you use, all the libraries you had at your disposal are now gone. Now go, right? Think about the time you adopted a brand new programming language that didn't have a strong standard library. Like I've seen people try to adopt Rust. Oh, there's no HTTP library. Oh, there's no, data store library. So then you're sitting there like, oh, I got to change my mindset. No, you just don't have any libraries. You're basically trying to fill in the gaps. So if you think about the earliest serverless talks, most of them were like, well, this is the limitation of the platform, so you have this pattern. Typically, when we see patterns, they're usually talking about a limitation. Like some of these design patterns are, well, my thing doesn't do that, so here's what you got to do instead. And so many people are doing this workaround, we call it a pattern. And it's like, well, maybe it's a pattern, or maybe if you were to support not scaling to 0, I wouldn't have to do all these tricks like ping my Lambda function every 5 minutes to keep it warm. I'm only doing this because I don't want that to happen, right? So wouldn't it be nice just to have an option that says, don't scale to 0. I'd rather pay for it, right? Like if I want to scale to 0, thank you for giving me that option. But if I don't want to scale to 0, don't show me a pattern where I ping it every 5 minutes to keep it warm. Like that's not a pattern, that's a workaround.
Okay. Anybody else? Lynn?
I was just going to mention, this is less of a question, more of a experience to share. But when I discovered Cloud Run, the main reason I was so into it was because I had years of experience developing Express applications. And I also happened to know Docker because my work had provisioned a Kubernetes cluster for us. So I was trained as soon as I started on how to write a Docker file. So I was just like immediately good to go. Like I could just take an Express application, copy and paste the Docker file from its official Express documentation. It's already made for me, really, and then deploy it.
So it's monolith.
And that experience that you just talked about was one of the key decision factors in this, because I think what most developers were wanting and from all of this was, here's my application, run it for me. I don't really want you to tell me how to write the code, but once I give you something and it has a decent contract like an HTTP endpoint, just run it. Maybe give me something I can configure about how things can call it, authorization, authentication, etc. But I wasn't really looking for a new framework. I already have one, right? Just run that one for me. And this is why App Engine evolved into something like Cloud Run, where we would give people that choice, because in classic App Engine, we were not friendly to all third-party libraries. Actually, you were getting a custom runtime. So you were actually dealing with a whole different execution environment.
Flex.
And true. And Daniel just mentioned something too. You mentioned the word monolith. Is that what I heard? That's actually amazing too. I loved how I was like, yes, they're going to let me deploy my monolith. They're not going to tease me for making one, right? So it's kind of like the scale to 0 example. Let me scale to 0. Let me keep one. Let me make a whole bunch of functions. Let me deploy a monolith, right? That's great. You got options.
Yeah, and if you really want to deploy one route container, you totally can knock yourself out and do that. But if you do think, from locality or performance perspective, and I've even done this in some of the functions I've written, sometimes it just makes sense to have one function and be able to do multiple things. So I just think having that flexibility by default is kind of nice.
But there is a saying like when the student is ready, teacher will come. So we had to wait quite some time. Every time I would meet Matt, he would talk about Cloud Run and I would ignore him. So eventually we opened up. So keep going.
More questions from folks.
I'm a bit confused about where Google just draw the line between App Engine, Flexible, and Cloud Run, because both of them run Docker container, right?
Yeah, so this is a great question, and I was at Google for about 5 years, so I was there when we were trying to figure out. So let's talk about some of the problems. So Cloud Run or App Engine Classic was this idea that you give us source code, you follow the App Engine contract, and you get all the benefits. And then time evolved, right? And then once Docker landed, the contract changed. Some people were like, "Look, I don't really need your build service. I don't care about things like build packs or your custom libraries. I want to use open interfaces. So if I want a cache, I want Redis. If I want a database, I want Postgres. I don't want any special PaaS-like thing, but I want them to still be managed, but I don't want to use any more closed interfaces." And honestly, over time, there were just much better frameworks and libraries like Spring Boot and so forth. So one thing we decided to do was say, hey, we can remove these restrictions if we just allow people to run their containers in a non-restrictive environment. So Flex was like, okay, what if we just took the same App Engine API and we allowed you to run on a VM under the covers, right? So this will let you do custom runtimes. We can actually do a few things that were a little bit hard to do in App Engine's infrastructure, and those things will be running in your VPC, right? So the trade-off there, though, was it was way slower to start up, right? It still is, right? You got to boot a whole VM, you got the kernel there, you got all of this boilerplate that needs to happen. But if the contract is just Docker, now that we have this OCI stable format, we took another look and said, you know what we could do is just kind of bypass all of this and just build something that's like Flex. Same, bring us your container, we'll run it for you, and we'll run it under the kind of App Engine style. So I think a lot of people that are looking at Flex today, Cloud Run is probably a good alternative to Flex if you want that performance, scale to zero, et cetera, et cetera. And with VPC connectors, you can still get into your VPC. So I think where we draw the line would be Cloud Run came after learning from what we learned from Flex. We learned that people like that style and flexibility, but I don't think people want a VM. They want to be able to scale to zero, and it needs to be fast. So that's what you get from learning after having a little bit of time with managed VMs was what's the thing before App Engine Flex. But where we are now is just give us your container and use standard libraries.
Cool. Next. What do you have in the chat?
I can ask a question from a perspective of, I do most of my work in AWS. So I'm, when it comes to things like orchestration and choreography, I'm used to using like event bus, choreographed events, and something like step functions for the orchestration of how you're going to call things under different conditions and putting the pieces of the puzzle together. When you do something similar to that, are you spinning up a sort of a master Docker image, which is the orchestrator, which then is using all of your other services? Or do you have a sort of a broader infrastructure piece that you like to use to orchestrate the various pieces?
Yeah, so this is where the industry is going full circle, right? So when we had the event, the enterprise service bus, we put all of our logic in the ESB. And once you put all your logic in the ESB, you live with that ESB for the rest of your life. And all of these digital transformations is because, like Jonathan, you're doing this today. In 5 years, 7 years, the person that comes after you can be like, what the hell is this? Absolutely. Who would put all this logic in this step? I got to parse this step function to figure out what's going to happen. I got to go look at this message queue. Oh my God, whose idea was this? Now we got to rip it all apart and put it back in the way we can maintain it. So I think there's some niceties there, though, which is I do have this kind of DAG of logic that I can look at and probably reuse. I have a central place to put everything, kind of like a load balancer, right? A central place to pull all this stuff. And then regardless of language, I never have to rebuild that kind of retry logic, et cetera. So if you think about the container community, so we do have a workflow engine like step functions that can actually be used with Cloud Run. or Cloud Functions because we wanted to make something that was independent of the execution backend. So I think there's a lot of people who agree with you. You can just kind of use that workflow type engine tool to give you this step functions like functionality. A lot of the Googlers have a lot more experience with things like gRPC and things like PubSub. So in that world, there's a lot more point-to-point that's definitely happening. And then there's a lot of PubSub that's going on, meaning if I need to actually talk to some service, you just kind of go point to point. And gRPC is super smart. It does a lot of the authentication. It does a lot of the policy. It does all the retry. Exponential backoffs are typically compiled and auto-generated for most people that are using things like gRPC, especially if you're using some of the Envoy type features that we call like the XDS protocol. And then if you need something that needs to fan out and you're not sure who your consumer is, then you're thinking about using something like PubSub, where you're just going to drop a message and then the consumer grabs it, right? And we also do a lot of what I guess people will call the CQRS pattern. You have some job ID that you're waiting for, and you don't know how many things are going to touch it downstream. So you'll just kind of fire and then go and reconcile to see, is this thing done or do I need to try it again? Or you reconcile on the later process with batch. So I think these are the patterns that have been around for a long time. Just a lot of people that are not using kind of the bus mentality, they tend to do this more on that point-to-point and a mix of maybe PubSub where necessary.
Okay, thanks.
When you mentioned step functions, there was an announcement that Cloud Next about workflow. Can you tell us more about that, or just?
Yeah, so the goal was to give people a way to do exactly what you're doing with step functions, right? Like we use like a YAML DSL where you can say, do this, then do that. There's some retry logic there. And the goal would be to give you something equivalent to what step function is bringing. So the vision we had there was, in this step, you might want to do something with Cloud Run. And this step, you may want to do something with Cloud Functions. Each of those can respond in turn. And then maybe it should also work with VMs and Kubernetes. Mm-hmm. So what our approach there was just make it more of a generic workflow engine that had built-in ability to call our execution backends, right? Mm-hmm. So for a lot of people, they would look at that and say, oh, great. So if I just have a bunch of VMs that can fulfill this request instead of a function, I can do that as well. So we just decoupled it from the compute platform. Mm-hmm. So I think step functions, I don't know how coupled it is to Lambda, right? I'm pretty sure you probably could use it with some other service, but we just wanted to make sure that it was an independent, isolated thing that you could just layer on top of any compute architecture.
Cool.
I see. So how do you deploy to that? It's just a config. It's just like...
Yeah, so we're big in the Kubernetes community with this declarative approach for everything. So the goal would be, you say, hey, here's the steps I want. If you've ever used Google Cloud Build, let me show you Cloud Build really quickly. I don't have a workflow example, but I'll show you Cloud Build because it follows a very similar syntax to that. So let's say you want to actually do some things programmatically, like our take on CI/CD. So when I built Badger, even though it uses Cloud Build to serve up these things, I also use Cloud Build to deploy things. So I have a cloud build.yaml. And when you look at this, I basically, I only have one step here. I had another one we're running tests, but basically you have a set of steps. And in this case, I run various, this is just going to build my Docker image and push it. But if you're using a workflow engine, you'll kind of have this like lightweight DSL that would say something like, on this step, do this. If this doesn't work, then do this, or call this other thing. And then there'll be some high level steps that you can call by name that have documented set of arguments, right? So wait 5 seconds or retry. And if that doesn't work, do this instead. And then ideally we use this format where typically you can articulate these things in YAML. Of course, you can see that, we usually support things like variables. And basically what it allows you to do is check all your stuff in. And then when you're ready, you can just use like the G-Cloud API to just push it to that service. And then your function is in place, or in your case, your workflow will be in place.
Next. Okay, cloud events. Like I heard you talk 2 years ago about cloud events, and then it was announced as a GA, I think, for Cloud Run, but not much more about that. And it sounds to me, I'm not sure, like something similar to Event Bridge that Amazon has.
Yeah, so one thing that's nice about Lambda that I always give them credit for, if you look at a lot of their managed services, they all tend to emit some events, and it makes this whole Lambda ecosystem really nice out of the box, right? And when we thought about, so there's a couple of things. When you say cloud events, we're talking about having a standard payload format, right? Headers, a body, and a way to decide what's in the body. So how we transport. So what we decided to do is adopt that envelope format for our eventing, right? So anything that's going to emit events inside of GCP, we're going to go with the CNCF standard. So ideally, even works outside of Kubernetes. The other things that or outside of our serverless platform. The other thing that we did was, when you think about calling, what is an event? And for most people, they just need a reliable set of infrastructure. So depending on how reliable it is it going to be delivered once or at most once? Will it have retries? How do you register these events, etc.? So we have a thing like that I think what you referenced earlier, which is kind of this kind of first party events, a way to register events, and then have some kind of SLA or contract on how they're managed. The other part of cloud events was for the simple case where some people say, look, I'm going to be producing events from my own apps, and I don't know if I want to go through your broker or register them in that way. I just want to use something like PubSub instead. So in that world, what we decided to do, let me see if I can share my screen here. We decided to give PubSub the ability to just push cloud events straight through it and give it the ability to authenticate to your compute backend of choice. So let me see if I can get this up really quickly. PubSub, here we go. I'm going to share my screen once I get this loaded up. But the goal there was, I actually advocated for this feature quite a bit, was I don't really care about having like a custom eventing language for the cloud provider. I actually want something a little bit more simple, and that way I can integrate it from my laptop, I can integrate it from other service, and I can also mix first party and third party things through the same channel, if you will. So when you think about PubSub, if I were to create, let's say like a subscription, we just have like this idea of like a push subscription. So you notice we don't have 7, 8 different message products. We have basically one, PubSub. So recently we added the ability for PubSub to do filtering, ordering, and for most of the patterns most people were after, we think this is pretty good. But ideally, most of our customers now, of course, we have first party events like something got written to cloud storage and we'll call your function. And we also want to route that to your Cloud Run instance if you want. But the idea there is that we just added the ability, maybe late last year or early last year, was to authenticate using service accounts. So you can say, hey, I want you to authenticate to my Cloud Run instance using a particular service account. So when I deploy my container to Cloud Run, I can drop in the URL that I get from the Cloud Run interface and then say, use this particular service account when you call it. And the audience is because if you're talking to a specific Cloud Run instance, you have to give it the audience as the URL of the function or the actual Cloud Run instance URL that we give you. And this will allow PubSub to authenticate using the default infrastructure that Cloud Run runs under. And then what goes through here are going to be cloud event wrapped enveloped messages. So you can use standard cloud events libraries to parse your messages. So in this case, we're saying, hey, how about we just use PubSub as much as possible? So third party and even some first party events can just flow through that using the open standard format. And then when it comes to our native stuff, again, we do have this thing called Event Bridge that will give people a little bit more control over retries, maybe some kind of UI, maybe kind of a centralized portal to think about events. But for people like me, I just kind of use PubSub and open it or Cloud Event Standard and just do it that way.
Okay, thank you. Next question.
Yeah, I was just going to say, does that PubSub implementation you were just showing, does that allow you to add a new subscriber and start consuming events as at a point in time in history? So can I say, show me, I want my new thing to start getting all the events since 10 a.m. this morning or something like that? So
we don't have that per se. We have a thing where you can replay, right? So I've used that a few times where I can say, hey, I want to replay from this timestamp all the messages and go forward in time. So we do have that, but I don't have what you just mentioned, which is I'm going to add the subscriber from this point in time, do the messages. So what would happen would be add the subscriber and then replay the messages.
But do all subscribers get all the messages?
To that one particular subscription?
Sorry, like
So-
if you hit replay, does everyone who's listening to that bus would get all the events again?
Yeah, so that's the pub sub model. So when I
Okay.
do a push, I'm doing one push description per function, right? So if I wanted to have only this particular container get this particular set of things, I would set up its own subscription from there. But this replay, yes, anybody on the other side of that pipe is going to get that replay.
I see.
Mhm.
Cool.
Danny, any questions?
And I heard that you mentioned about ordering, which is new to PubSub. Can you talk a little bit about that?
Yeah, so we just dropped it in beta last week. I just shot out a tweet about it, but a lot of our customers that were just using Kafka simply because we didn't have ordering inside of PubSub, there's nothing wrong with Kafka, but as a managed service, it's just like people are like, look, if it just had ordering, I would just use it. So people used to do all kind of tricks trying to get like a ordering ID of their own and try to do this, but it's a hard problem to solve. I think there's a lot of things to have solve it when you localize a cluster, but when you start to go over multiple zones, the system you need on the back end is a bit more challenging. So this is where things like Spanner come in. The reason why we have more consistency in Google Cloud Storage is because we use Spanner for metadata. Now the same can be true for PubSub messages. So what can happen now is we can tell you that you can now have an order. So this is not going to be guaranteed once delivery, right? You still may get a message more than once, but it's going to come in some order, right? And also when you do a replay, you're going to get the replay back in a particular order, right? So if you miss a message, let's say you miss message number 5, and you go to replay, you're going to get all the messages from 5, and then going forward, you'll be able to catch up that way. So the ordering is kind of done in our back end. It is regional, so it's not global, right? I think global will require a little bit more work on our side, but at a regional level, multiple zones, you will have ordering to your messages, and you just turn it on when you create that particular topic, right? You just say, hey, I want my stuff here to be ordered, and we'll do the work on the back end to do the ordering, and you'll have some order ID that you can look at.
Cool. Don't be shy, speak up.
I have another question. So Kelsey, you showed us the Badger example earlier. Other than that, what's the most interesting thing that you've made either at Google or in your personal time using Cloud Run?
So what I've been advocating for is that I should be able to replace VMs completely with Cloud Run. So what does it take to have that? Because it turns out most of the applications that make most companies money are not the little microservices that they're writing. It's a lot of the other stuff, especially for the larger companies. These are off-the-shelf components because not everyone's going to build a HR system from scratch. People are not going to be building some of these other things from scratch all the time. These are things you're going to buy from a big vendors because they're a problem that just takes so long to solve, especially when you account for regulation. So REST APIs, I think we have lots of platforms for that. So, you got people running things like game servers in Cloud Run. You have a lot of the game servers, games you probably played are running, some of their backends are in Cloud Run. So my goal has been, I want Cloud Run to be able to mount GPUs. I want it to be able to mount storage volumes. Because if you think about the difference between Cloud Run and GCE, they both run on Borg, which is our internal infrastructure, kind of like Kubernetes. And the VM case, we create a container and we run a VM inside of it and let you have it. In the Cloud Run case, we just run your container side by side. So if you were to look at our infrastructure, there's probably a mix of Cloud Run instances and what are considered VMs running side by side, slightly different networks, et cetera. Imagine a world where you can say, I have a container that needs a GPU. I need to be able to bind to multiple sockets. I need to write to a local volume and have all that run in my VPC. Cloud Run is on trajectory to try to do that. So you basically will be able to run anything I can run on a Linux server would actually work here. And you can treat it serverless. So if you want to scale to 0, great. Or if you want to have it stick around after the initialization, great. So I've gotten Jira to run, a ticketing system. I've gotten some game servers to run. I'm now running a lot of these cloud native projects like Open Policy Agent that people use for auth capabilities. There's lots of control planes that I want to take out of my infrastructure and just run serverless because there's no need to really run those inside of Kubernetes. So my goal is to take as many control planes and just put them in this simple place. Like, imagine running Prometheus if you're going to have your own metric solution in Cloud Run. So that's the goal for me. Cloud Run should be able to run third-party apps that developers didn't create. And I think that's going to be a game changer to run some of these off-the-shelf apps in a serverless capacity, right? Because I might just need a dev instance of Jira because I'm writing a Jira extension. I don't want to run that on the whole VM. I want to have it just scale to 0. When I need it, it will come back up, connect to Postgres, and off I go. That's the world I want to enable. Can we bring the serverless mindset to existing apps with little modification?
It's a big one.
That's really interesting. If you don't mind me expanding a bit, do you see that happening with databases too? You use the example of Postgres, but like things like Elasticsearch, that's something that we struggle with at work.
So the problem with those kind of databases where they expect data to be local to themselves, right? Like they are tuned for high IOPS, right? Like I have a local disk and I'm going to do some high IOPS, and any disruption, that's going to be a problem. If you think the way Spanner and BigQuery are implemented, the compute layer is separate from the storage layer. So effectively, this is not how it actually works, but effectively what they do is they come up and they use a storage service, and they assume that that storage service is over some remote RPC call. And that way they can actually deal with storage, whether I turn it to 0 and bring it back up again. We don't have to worry about them assuming that they're going to have fast local IO. So if you think about a traditional database, the reason why I do want to be able to mount a volume is, yes, you could scale to 0 and scale back up, and your data volume would be there waiting for you. And then it will be, I don't know if it will be perfect, because again, most databases benefit from having a lot of that data cached, right? So minimum instances is getting there, but the way minimum instances is implemented today, we freeze your process, right? So freezing a database process is probably not a good idea for all the background work it does in terms of dealing with indexes and B trees and all of those things. So I don't know if databases, the current ones on the market, are suitable, but imagine a world where I do say, look, I want to treat this Cloud Run instance like a VM. Don't freeze my process, and I'll just pay 24 hours for the cost of running this thing, even though it's idle, right? So that's something that I'm interested in being able to do. I am believing that there should be no app that runs on Linux that can't run in Cloud Run.
That's cool. Next. Good, I see you here. Are you playing with Cloud Run nowadays? Or it's still Firebase? Okay, he's on mute. Trying to poke him to ask you a question.
Oh, so here's the thing. Someone said strategic legacy apps on VMs are built packaged with large Java 9 web app servers, WSL, WebSphere, Tomcat, JBoss. Shifting to containers, serverless are 100% different arc and deployment model. So this is interesting, because I've met a lot of clients over the years who's like, oh, this big Java thing is no way. And I'm like, and I put it in a container for them and say, look, the biggest difference is most people probably don't know what the hell that application server is doing to their machine. Like it's probably running as root, touching God knows what. Who knows what type of, how many threads is spawning out. Oh, look, 4 cores, I'll use them all. 2 terabytes of RAM, I'll use it all. Like there's no, like most people have not even tuned the JVM. I'm seeing companies throwing memory and CPU at the JVM. It's like, why are you running with the standard JVM config? Like you can tune the JVM for what your needs are. So the first step that we've taken with a lot of customers that are running these existing apps inside of these big application servers is, first, can we tune the JVM to make sure that we know what the performance, what the garbage collector is doing, parallel GC, etc. Second was, we try to make clear that if your JVM thing is tuned for like Red Hat 6 or 7, then make Red Hat 6 or 7 the base layer inside of the container. Don't get fancy here. If you're using a particular version of Java, put that version of Java in the container. Let's not reinvent the wheel. Let's try to bring as much as possible. The second thing here, where when it works, typically these apps will run. We do turn off the things like scale to 0. This is why we have min instances. Don't scale to 0, because some of these apps take a long time to start. I actually remember booting one of these kind of Java apps, and it had a timer in the logs. It said like 1 more minute until initialize. I'm like, literally, like you can count minutes to initialize, but that's the reality of it all. So that's why we wanted to support the ability to get on. Now, the things that don't work typically in the cloud is when you start doing some of this, clustering that JBoss used to support with this whole multicast stuff. That's when things start to fall on the floor. But if you're just got like a Java app that just needs to start, make some Linux calls, we can do that. And I think we can do that pretty successfully in an execution environment that gets you very close to a VM.
Questions?
Hey there. So, if I can change the subject a little bit, more about Go. Is that okay?
Yeah.
So I know I'm behind the 8 ball. I've been avoiding learning Go, mostly because I'm so accustomed to my tech stack. And one of the things I work on my tech stack is the dynamic languages and the ability to have a REPL. And I miss that for exploration, stuff like that. Is there similar for Go because it's compiled?
Yeah, so my first real like programming language was Python, and man, I mean, I used to contribute to pip and disutils at the core library. And you're right, like having that REPL where you can just like dive in there and do a bunch of stuff, right? But I felt I needed a REPL in those languages because I don't know what this thing is, right? Like if someone gives me like a thing, I'm like, what methods can I call in it? So just like dot and then try to tap out to see what I can do with it. And then I'm not even sure what's going to come back. Am I going to get back a dictionary? Am I going to get back a string? What am I going to get back? So I found the REPL helped me really rationale what to deal with when it's dynamic language, because it felt like anything could happen. When I write Go code these days, so I switched to Go when I started contributing to Packer from HashiCorp, right? HashiCorp, everything was written in Golang, so I had to learn Go to be a contributor in that community. Also, the system administration part of me was like having that static binary. So when I learned to Go, I started to deal like, oh, these static types, all this boilerplate. Let me share my screen real quick, and I'll tell you how I kind of got over the hump and why I think I found it a bit easier to reconcile. Number one, I used to work at Puppet Labs as well, and I used to write a lot of Ruby. And Ruby is like, you can do anything, right? Like you have this REPL, I can do meta programming. Oh my goodness, it felt like it was the world. But going back and try to maintain that code was even more of a challenge, especially if someone else wrote it. But if you think about the Go world, for example, Go is going to require you to be a little bit more clear about what you actually mean. So for example, if I'm connecting, I'm going to show you, this might be too simple of an app. Let me go to something maybe a little bit more complex. Yeah, this is me refactoring too cleanly. Let's walk through like a little calculator service that I have. So for like most people, if I'm building an API, I'm just going to show you like this kind of little monolithic app that I built. It has a couple of libraries, but basically it's a calculator app, and it has add, subtract, whatever. So when I go to build apps like this now, the overhead of Go is going to say, hey, you need to give us types. Like, hey, here's a type. This is a request. And to add things together, you're going to have a set of add-ins, and you're going to have this integer type. So I looked at this as like, damn, that's a lot of boilerplate. But here's the thing. When I come back to this, I know exactly what needs to go in here, and the compiler catches it. If I do it wrong, it won't even build, or your IDE will catch it ahead of time. And also the IDE's ability to do auto completion when it has all this type information, right? This is why I even think the Python community try to add some type hints, and I think Ruby is also doing the same thing. But when I read this code, there are no objects. It feels like a lot of procedural code here, right? If you look at this, here's my HTTP handler. Everything just reads very procedurally, all right? And when I wire this up, so I'm going to show you the thing I actually deploy. So that's the library that does adds. But then when I go to the actual service, I'm going to show you how much code I end up writing. And it's highly performant, right? So like the trade-off here is that I'm getting something that can handle 10,000 requests in a second if I have enough CPU. I'm not going to be writing that kind of code. So when I look at this now, again, my flags even require to be typed. But here I just registered that little add handler and then just listen on some config socket. And this is going to be about 35 lines of code. But again, this high performance HTTP server that's built into Go is straightforward. So all of this type information for me, I don't know, just for some reason, it just made me feel like I don't miss the REPL anymore because I'm no longer guessing. I know what the fields are to this handler. I know what the type needs to be. So I just don't think about walking code that way anymore. I don't know, it's weird. It's like when you go from dynamic language to type language, it just feels like the types communicate more than trying to do this like live debugging session about what's about to happen. So in the Go world, I haven't missed it, but I definitely have empathy for where you're coming from. It's like, you know, having the ability to do that.
Right. Yeah, I came from the Java, then I went to the Ruby and the JavaScript, and now I think I'm, we're going back, right? So it's not like it's foreign to me. It's just I'm just wondering, how do you debug these kind of services in production, right?
So let's
Is it
talk about
just-
that. So from debugging in production, since we have all this type information, there's debugging tools built into Go. You have a lot of type information that you can hook up things like the old school debuggers, or there's a program called Delve that people will use to debug, kind of like you did in the Java world. Connect to a socket, you see all these objects, and Go have some built-in handlers to do this as well. But I'll tell you what I don't debug. So when I was at Puppet, we used to have a lot of weird errors like, oh, I didn't know that this object will return one of those. Oh, I got monkey patched by this JSON library I imported. Didn't expect this thing to do that. In the Go world, typically when I compile a binary, I'm not debugging types, right? Like if you've written unit tests in Ruby and Python, half of your unit tests are, I expect to get this type back. In Go, I don't spend time writing type tests. Like that's not a thing we do anymore. So typically when it builds, I can't think in 7 years, and I've contributed to Kubernetes. That's a big open source project. I've contributed to a lot of the tools over at HashiCorp. I don't think typed stuff is where I trip up on in terms of debugging, right? And the other thing I do is I also put my logs. I typically log, again, since we have all this type information, I can also just add exactly where in the source tree I am. It's kind of built into the Go. We have a runtime in the standard library. It tells me exactly where I am and what types are interacting with each other. So that kind of debugging really gives me some shortcuts. And then, of course, you can always do your breakpoints and stuff if that's your style of debugging. But if you're like Rob Pike and some of the old school Linux people, I put print statements still, and I'm printing out various sections. So it's up to you, but there's also first-class debuggers if that's your jam.
I must add a comment.
Thanks.
We're going to go full circle with technologies. When you're talking about Go, this reminded me of Brian Kernighan's Go programming language.
Yeah, I bought that book. I bought that book back in the day, and the thing I liked about that book, I think it's about 100 pages, and it gets straight to the point. When I learned Go, I actually found this very simple book. It's like Intro to Go, and it's probably less than 100 pages. But I've been able to contribute to etcd, Kubernetes, my own project, CompD, various libraries. It's just really good at that kind of stuff. I wouldn't write a UI with it, but it's really good at the back-end stuff that it's designed for.
That's a print book, Intro to Go.
Yes.
Okay, it's on my bucket list. But I didn't
It's
know
free. The PDF is out there. I think I learned Go in about 2 or 3 days because all those other languages, you have to learn about objects. And if you're in the Ruby world, you have so many things you can do with modules and indirection. And when you're reading someone else's code that's doing all of this stuff, you got to know what the meta program is doing. Are they injecting? Are they hijacking? Module lookup paths? There's none of that in Go. Go typically reads straight down the line. If you can read it once, you're like, oh, okay, this is what's happening. Maybe it's not elegant, but boy, can I read it.
Okay. And when you were showing sample of your code, it's kind of related to deployment. You show the shell script, how you're deploying it. And there are 2 ways. There is imperative way and declarative way of deploying. I like what you deployed. It's a little shell script for deployment. So lots of people are advocating just Terraform or like, CloudFormation.
Yeah.
I like
Yeah.
what you did over there. Like it's imperative, but it's infrastructure to code.
Yeah, I think a lot of people, even when I worked at Puppet, there was a situation where people will overdo setting up the foundational bits like service accounts, API gateway, and maybe even the initial function, and then the stuff that you do day 2, which is the inner loop of development.
Mhm.
When it comes to inner loop, there's no way I would want to use Terraform to do inner loop development. Like I'm not setting up a service account every time. So I usually like to do references inside of my kind of deployment script. So for example, when you saw me deploy to Cloud Run, I usually set up the service accounts and just make a reference for them. So when I'm doing development, my type loop is usually /deploy, /build, /deploy, /build, assuming something like Terraform has already run to set up all of my dependencies, databases, username, passwords, etc. So I decouple those, right? You also see this in the Kubernetes community. Once you have a cluster, your inner loop is very different than what it took to set up the cluster.
Okay. Because it sounds like database setup, database description language, database manipulation language. You separate the 2.
I do, yeah, exactly. You know what? Yeah, these are a lot of the fundamentals I think people are rediscovering, is that you don't necessarily need to use the same paradigm for both.
Yeah, but that's the dogma we were talking about at the beginning. Like once discover one tool, they want to solve every problem with it. Okay, that's fair. More questions? Lynn is gone. I was hoping she's going to ask something. She has really good courses on everything, like so. Anybody else to ask questions?
I have another question, and this actually goes back to Cloud Build that you were talking about earlier. Kind of missed my chance to ask it. Basically, I was playing around with deploying Cloud Run using GitHub Actions recently, and just because I'm a little bit more comfortable in GitHub than I am in Cloud Build, and all the tutorials for Cloud Run they had you have Cloud Build the Docker image, and I was wondering, is that really like the only way to go?
Not
Because
at
I was able
all.
to get it faster just to build it in GitHub Actions and push it.
Exactly. So the whole point behind Cloud Run is that you can use any tool you want. So for example, I don't have Docker installed on my laptop. I haven't had it for like 3 years. I typically use Cloud Build. I just like using some external build service. But the whole point of Cloud Run, and one of the litmus tests we used was, can we pull standard images from standard registries? So I think one thing would be, I think today I don't think we require it to be in the Google Cloud Registry. So you can build a Docker image, push it somewhere, and as long as we can access it, then we can pull it at runtime.
Cool. I think that might be fairly recent news then. Last time I checked, it had to be in GCR.
So that may still be true, right? So how you build it though, right? Some people will use Docker on their laptop, Docker build,
Yes.
Docker push to GCR. And I think the reason why we have it there is because the way our internal infrastructure works to make all this fast, we need to have fast access to the repository, right? So what some people will do is just mirror it. So maybe you're comfortable pushing to your own Docker repo, but for deployment purposes, you'll just mirror it into GCR so that way we can pull it fast.
Mm-hmm.
Cool. I just basically wanted to ask because I wasn't sure if I was breaking some sort of rule, like, oh, this is not a secure way of doing the build. It's glad to hear I wasn't crazy.
Nope. Yeah, you can do the build however you want. Just out of convenience, we have a default option.
Cool.
That's cool. Who's next? Guys, don't be shy. Kuds, I keep poking you. Kuds.
I like to expand the conversation to Cloud Run on Antos. How do you envision that being used? Where does it fit in?
Yeah, so when people think serverless, I think personally, I think fully managed, right? I don't want to see any servers anywhere. I am in agreement with that mindset. Now, let's say you do have a cluster on-prem, you're using Kubernetes already for stuff, and then you say, look, I don't want to go and teach all of my developers Kubernetes. I say, hey, all right, all that YAML, kubectl, etc. I like the abstractions that Cloud Run brings, right? So when we did the whole Cloud Run on Anthos, the idea would be take a Kubernetes cluster, connect it to the Cloud Run control plane, and then that will become our execution backend. It's just like when you have a CI/CD, you can bring in your own build workers. It's the similar model, right? So you attach your cluster. We would install for those that don't know, Cloud Run is backed by an open source project, Knative, which is the high level primitives, a declarative way of thinking about events and compute, scale to 0. There's some controllers, there's some control plane components. And you can use tools like Istio, even though you can use other networking to give you some of the things like traffic management, API gateway functionality. So Cloud Run for Anthos says, look, Google already has our own control plane components that implement the same interface. You could just run those components in your own Kubernetes clusters and you have everything to scale to 0. You have everything to mount secrets and manage traffic. So why not hold ourselves to this kind of open standard where if you don't like Cloud Run anymore, you actually can go to the CloudFront UI, get the Knative object out and call kubectl apply against your own cluster. As long as you have the Knative components installed, you can get that via Cloud Run for Anthos or just install open source Knative. So the goal there was to give some people the checkout story, but also there are some more capabilities. If you're running like something like GKE or Kubernetes in some cloud provider, it doesn't matter. You can install open source Knative anywhere. Cloud Run is going to give you the UI and all those things. But if you're just running Knative, the nice thing is you can actually have your containers run on a GPU. You can mount storage in there. You can pretty much do all the things Kubernetes will allow you to do. So that's kind of an added benefit of running. Keep the extractions high level. I want to tell my developers they can have a Cloud Run like workflow, but I can actually start to leverage some of those things because I am running on a VM instead of a Kubernetes cluster. I can do things that our serverless platform doesn't do today, which is mount volume, storage, GPUs, the whole nine.
Cool. And I'm always a little bit skeptical of the new technologies. So Anthos is a nice Greek name, and until I saw announcement that BigQuery runs on Anthos, can you tell us a little bit about you, like eat your own dog food? Like, looks like you are practicing that because BigQuery is made available through Anthos.
Yeah, so I think what's happening in the industry is there was a vision years ago where people thought everything would just go to the cloud eventually. Turns out that is not actually going to happen. One is there's just going to be reasons why you want to just run in a different compute environment. And there's so many workloads right now that have nothing to do with containers or VMs, right? All the stuff that still runs on mainframes, people laugh at it, but more than likely you're using something back my mainframe right now in your daily life. What do we do about all that stuff? So what's going to happen? There's factory floors and retail stores and theme parks. That stuff is not going to be in the cloud. You don't want your hospitals services to be like, oh, we can't check your blood pressure because we got to go to the cloud first. So too bad you died. That's not going to work. I need as many of those things to be very low latency, full stop. Whatever the overhead for going to the cloud in those use cases, I want it all back to stay on that kind of premise. So given that, what does it take to run things like BigQuery? Well, we need an orchestrator, and we hopefully need something that looks like Borg internally, and Kubernetes gives us a lot of those features. So when we start thinking about how do we bring more GCP services like Cloud Run, some of our managed databases, we need an orchestration layer that will allow us just to bring the control plane, whether we use a GCP control plane, which still runs in the cloud, but when you click around to launch something, we can execute that in the cluster because there's enough orchestration bits for us to give you some of the things like failover and mounting and some of the things you see in GCP. And that trend, I think, is going to continue. You see, Amazon has a slightly different approach where they give you outposts where you have a physical, machine on the edge and the premise. But if you think about it, all cloud providers are actually moving in that direction to say, look, what if I gave you infrastructure and then you can run more of my services in your data center? That makes a lot of sense going forward. So that's where this is coming from. So if I'm going to give you BigQuery, I do not want to try to support that on OpenStack, VMs, and random hardware.
Okay, I have a subsequent question. So I've been working not on Google projects, but Amazon projects, migrating people to the cloud. It's a whole different mindset. Now we're going to be migrating them to Anthos on-premise. What are the changes you need to do? Is there a different migration guide? How do you train people to modernize their own data centers and feel cloudy?
The thing about this whole modernization thing, I think people are just confused a bit here. I think people started abandoning their software. Like, you got this app, you don't update it, you don't even keep, if your app is written in Java, doesn't mean it's legacy. But if you stop updating the JVM, then you've abandoned the software. If you haven't updated your libraries and your frameworks, you've abandoned the software. So for some people, modernization is simply just updating the software. For a lot of people, get the latest version of Java. You might actually have to rewrite a little bit of code if things are deprecated or found insecure. For most people, that's 90% of the journey. The other part is leverage. If you told me that there was an environment that had a universal health checking infrastructure like Kubernetes does, right? Like, if you have a /health, then Kubernetes can check that health, then propagate it and use it as part of service discovery. Cloud providers also have something similar. Is that modernizing? That's just health check. Is metrics modernizing? That's just sending metadata about what your app is doing. So I don't know if this stuff is modernizing. I think it's more about leverage. We know that there's these patterns that you can leverage. Some of these patterns require code changes. Some patterns, like some of the things that we just talked about, you can actually do with these sidecars. So this is where this whole service mesh comes into play. Someone mentioned earlier about JBoss and WebLogic. We're kind of going back to that. When you have an application container that is trying to be super smart, handle database connections, connection pooling, HTTPS, and then you can write a simple app, a lot of the service mesh stuff that we're talking about essentially is doing that. It can do protocol translation, it can do retry policies, it can do authentication, authorization. So what then happens is I can take existing apps and put a sidecar on the side, and then it can inherit some functionality that things like Envoy and Service Mesh and Istio have, because I don't need to rewrite the code to take advantage of those things. I can get some things that way, like certain type of logging. I can convert standard out into structured logging. It won't be perfect, but you can start to adapt some of these things. If you want to take 100% advantage, and then yeah, you're going to have to add some more code, right? Like if you want to give me detailed metrics about a certain thing, then you're going to have to give me a little bit more metadata about what's happening inside of your functions. On the outside, I can tell you what the client is doing. I can tell you what the response was, but I can't tell what you were doing in the middle, right? So that's where depends on how much leverage. So that's what I mean by modernization. These platforms have so many functions and features that sometimes you're going to get them by just being in the platform, and some of them you're going to get by adding a little bit of code to take advantage. I'm going to answer one of these questions in here about OpenWhisk. What does Kelsey think about OpenWhisk on-prem? I've deployed a cloud like Apache on-prem in critical regulated industries. See, when it comes to like OpenWhisk, again, these are just like small veneers over a part of the development process, right? Like give me an API that make it easier to deploy an app. I truly, well, some people, deploying an app is the hardest thing that they'll ever do, but it shouldn't be. Like if you understand how to deploy software, this should not be the hardest part of the stack. And this is why we have 10,000 of these frameworks like, oh, deploy it this way, deploy it that way. That typically isn't really the problem for most people. But the reason why things like OpenWhisk and Cloud Run for Anthos are popular is because they take all the decisions out. No more debating, how do we copy this WAR file in this directory? Do we use RPM? Do we do apt-get? So killing the conversation and taking an opinion path is where the innovation is there, not the fact that it's a container. So what do I think about it? Look, for most of these on-prem environments, it's nice to have an opinionated way backed by the industry that will keep it updated and maintained, and you just get to get the new features and benefits from it. But this is very far from cloud. Having an easier way to deploy containers is no match for like really having horizontal scaling, multiple regions, smart load balancers, and all these features. So I don't want the industry to get complacent thinking, oh, I can deploy containers on VMs on-prem, now I'm doing cloud. No, you're doing containers on VMs. Cloud is so much more than that, but I think most people may not really have a need, which is why they think that they're at parity.
Cool, thank you. Next question. Guys, this is unique opportunity to chat with Kelsey.
Well, hopefully it's been fun so far, you know.
I'm loving it.
There's a lot to this whole cloud thing.
And Jay, so we have lots of quiet people that are really knowledgeable guys, but just intimidated.
They don't have to ask any questions. Sometimes it's just cool to kind of be a fly on the wall. So I respect that too. How are we doing on time? I mean, I'm happy to go a little bit longer if people are enjoying it.
Normally we are 6 to 8, but nothing stops you from going longer or shorter. My wife is with her mom, so I'm fine. So anything else? So how about like migrating Windows workloads? Like everybody's jumping on that, like Windows is up or falling off the chair. Like just kind of we are touching migration, Anthos, everything like nothing else.
So here's my thing. My thoughts on migration is that I've had every job in tech. I've been the person who worked in the enterprise financial institution for multiple years, where you have some COBOL, you have some old school Java stuff, and then you say, look, I want to take advantage of, at that time, Puppet was the latest and greatest. You know, putting things in RPMs was the latest and greatest thing you could do at that time. So I always looked at it as a pragmatic thing. If you want to use RPMs and Yum servers, then you're going to have to learn how to write an RPM spec file. If you want to do it right, you need to learn how to do an RPM spec file, because if you learn how to do an RPM spec file, then you'll know how to actually do things like shut down the apps properly on the upgrades, handle all of the lifecycle management things that RPM brings. If I use a migration tool, I have no idea what the migration tool is doing. I haven't learned anything, and I can't take full advantage of all the unique things that RPM provides. So a lot of people are kind of looking for shortcuts. I don't want to build a Docker container. So let's talk through this for a second. Forget Anthos Migrate, just any migration tool that you've ever seen in your life. I have this VM. The people who know how to manage this VM are gone, and no one can touch the code because no one wants to touch the code. Great. So that's already a problem. So what you want to do is this VM that nobody knows how to patch, no one knows how to upgrade the code, meaning I can never do health checks, I can never do anything. So I'm going to take this VM that I know nothing about and put it into a big container. And then I'm going to put the container where? On Kubernetes. Okay, let's say you get this to work. How do you patch the OS going forward? Some people say, oh, I know, Kelsey, I got it. go back to the original VM because we never turned it off, patch it there, and then run the migration tool again. I'm like, what are you doing? How's this better? The thing is, if you learn how to actually do a Docker file, the tedious nature of writing a Docker file is that you need to know what's going on. I need to know what needs to be inside of the bundle when I'm finished. Guess what you get then? Now you get the confidence that if the machine crash, I can at least repackage the thing. I can at least move it around, and I know where to go do my patches for security vulnerabilities. So I think this kicking the can down the road mentality may not be beneficial for people long-term looking to do simple migrations, right? Because if you don't understand the thing enough to be able to write something natively for it, and we're not talking about a lot of code changes, we're talking about being able to adopt this packaging format. How do you troubleshoot something like that? That's the thing that just, I don't know, that one is like, I just worry for people that don't want to understand the thing that they're going to be responsible for managing.
Kelsey, I think that's a side effect of the industry, that people abandon the apps, like you say. Executives don't know what they have, and they're using excuses, third-party companies, and they kind of charge them arm and leg to migrate. Nobody has a clue what they're migrating. So garbage in the basement is garbage in the cloud. So it's just side effect of illusion. Oh, go to the cloud, and nobody can tell you what you're moving. So that's how I feel.
No, and I think there's a lot of truth to that. So I tell people when they ask me, Kelsey, show me the easy way. It's like, look, I can show you a demo that I spent years learning how to perfect. But in production, someone's got to know what the hell is going on. I promise you, someone's going to have to know. And I think that's what people have to consider when adopting these new technologies. Like, for example, you're not supposed to worry about infrastructure stuff with Lambda. If you've been using Lambda for a long time, you have gotten an email that said, you need to update your function. We're deprecating that version of Node.js. You need to update your function. And some people be like, what? What function? I haven't looked at that thing in a long time. How do I package this thing again? How do I deploy it? Will it even work? How do I test it on my local machine? Oh my God. This doesn't seem like it was so convenient as it was when I did the first deployment. So there's these things where you still need to be aware of the runtime at some point down the line. There's no way to get away from 100% being absolved from what's going on underneath. Either the cloud provider upgrades you and your stuff breaks. Anyone here have a function that doesn't deploy anymore because they've deprecated your runtime? It's past. See, Matt raised his hand. It's like, so that fallacy of just build it once and never worry about it again. No one can make that promise forever.
Correct. Agree. Anybody else? So about I keep going back to migration because somehow most of my job since moving people from Sanos to Solaris were about migration. So I always end up with those contracts and the Windows migration. So tip is like you're talking about patching, but really you have to look at the app. So my tip for developers before was just go 12-factor, like learn how to apply 12-factor practices. So you can be pretty much cloud native on-prem. That's that slide with the ladder. You can start there. So it's not just
let's talk about 12-factor for a second. Like, to me, this is another workaround that got turned into a pattern. Right? So think about it. Heroku doesn't support config files. Right? So what do? You say, hey, forget config files. Let's just put everything in an environment variable. And you say, well, what if my client library needs to use TLS search to connect to the other side? Put it in an environment variable. Oh, Unix doesn't. That's when you learn that Unix actually has a size limit to how big an environment variable can be. Things you wish you never had to learn before when you get an arcane error. And when Kubernetes came out, it kind of showed people that 12-factor doesn't have to always be about using environment variables. I do agree with the separate your config from the code, but we can still put config in config files as long as the platform knows how to inject them just in time, just like the platform populates environment variables. So this is one thing we're going to be adding to Cloud Run, where you can actually start to mount secrets like you can in Kubernetes, right? This idea that I can say I have this large XML file because it's a Java app, or you have a large JSON file. You can still store that in the way you would, instead of putting it on a specific file system, give it a name, and then when your function or container runs, we will mount it in the path that you tell us. So you would say, I have this config file stored as a secret or a config value. And then in Cloud Run, I can actually update my deployment script to say, go get this secret named foo and mount it to Etsy app name foo.json. and then it will just work. So you can still have the same cloud native or 12-factor patterns, but we don't have to restrict ourselves to environment variables. Because if you start putting secrets like database passwords in environment variables, you're going to have a bad time at some point.
I agree. But people have to have guidance, like at least it doesn't have to be dogma, but some guiding principle that can be violated. Every rule should be questioned. So I agree. Thank you. Next question. Or what do you feel like talking? Like, is there anything we didn't ask and you wanted to share? Like, we don't know much about Kubernetes and service mesh, and then, well, at least me and folks coming from AWS side.
I have a bit of I guess it's a small clarification. I recently started using Cloud Run, and I really love that. Previously, I was just writing small jobs using Cloud Functions. What's the key difference between the two, or maybe why would one use Cloud Functions now that we have Cloud Run? I'm assuming it does everything that Cloud Functions already do. That would be a nice clarification.
I'll let you answer the question first, and then I'll add a little bit on top.
For me right now, I have a little. I deploy basic Express servers to Cloud Run, but they still do very small jobs. It's nothing pretty big. So my question will be: is there any need for using Cloud Functions?
Yeah. So this came up too internally, right? Like, we now essentially have two ways of doing this serverless style thing. So FYI, our plan is to basically take what we call the functions framework, so that when you use Cloud Function, you're using what we call the functions framework. And when you give us your, let's say, your Express code, we actually build a container underneath with our worker code that then kind of injects your app in there. So it's just like if you would have done it yourself. But we call that the function framework that's backed by this worker. And what the worker does, it does things like get your logs from standard out and sends them to Stackdriver logging, et cetera, et cetera. But if you look carefully, when you push the Cloud Functions, I don't know if we still show it, if you go to GCR, you'll actually see the container that's built for that function. So you're actually still using a container under the hood. So is Lambda, by the way, but in a different way. Now, when we looked at Cloud Run, one of the goals was it should also be able to work with Cloud Functions. So what you can do, even on Knative, where you're running the Cloud Run stuff inside of your own cluster, you can use the function framework. And what that will do is basically treat it more like a build pack. So the goal would be is to take Cloud Functions and run it on top of Cloud Run's infrastructure. Then the choice is going to come down to which UI do you like better? Do you like the idea of just like having a simple function signature and mapping events to that? Because that's going to be a workflow that a lot of people like. If you're more in the container world where I want to run something that works on Docker, works on my laptop, the function signature isn't buying me very much. So I'd rather just import the Express framework myself and use my own libraries for everything, including caching stuff if I want. And what I'm finding a lot of developers, especially because the thing is, I think when Heroku came out and this idea that all this stuff is hard, we didn't have as nice web frameworks as we do now. Like we had Ruby on Rails, but I don't remember a plethora of great, low, small, nimble web frameworks that had all of these other nice libraries, like to do HTTP tracing is just one import statement. Now that we have all that, do we really need build packs? Do we really need all of this stuff to build us for us? So I think at this point is choose your interface that you like best, that works best for your workflow. If functions get you by, use a function. If you like to bring a whole container image, meaning you control the runtime, then you can bring them. But ideally, both of them are going to be running on Cloud Run's infrastructure. So you're not really making a compute choice in terms of Google's perspective. You're making more of a who owns the container, you or us?
Okay, makes sense. Makes sense. Thanks.
Cool. More questions? Different glasses.
How configurable is this scaling on the Cloud Run side? Like what
dimensions do you have? Yeah, you're talking about what dimensions? So let me share my screen really quick. So you talked about how configurable is that? So I'm just going to jump to my desktop really quickly. So if you talk about Cloud Run, let's talk about what it takes to deploy. So earlier when I was talking about like this Badger service, I typically use like a little deploy script like this. So here I'm just basically saying, if I usually do one instance for now with one CPU. I think you can do up to 2 to 4 CPUs, and I think we're going to like 4 gigs of RAM too, or maybe even 8 gigs of RAM in alpha. But basically, one dimension you have is how much concurrency. So since this is written in Go, I can do a pretty good amount of concurrency with just one instance. So cold start, it's running, and then how many concurrent HTTP requests should I route to this, right? So that's the first thing you get. So the next one is going to be, so gcloud run, let's do deploy, so we can just look at some of the flags. So the other dimension that you're going to get is going to be the max instances. So unless you want to give us all of your money, right, you might want to control the max number of container instances that we can have running at one time. And let's see if I have my console up. So the goal there would be, I think we expose it in the console, how many billable instance hours you have at a given point. So if I click on this Badger container, we're trying to be very transparent on how much you're actually spending in terms of billable container instance time, right? So it's going to be basically, we charge you when the request starts and when it ends, which is nice because it's not about necessarily when it's running, et cetera. So how much compute time? So if you keep this to 1, then it's just going to be 1-to-1 based on your concurrency, and then we're going to charge you at the millisecond boundary. Or you can say, look, I want to have 100 of these. Maybe I have something like Python where it's not going to be able to handle any concurrency. And in that world, you might say max instances are going to be like 100. And then at that point, we're going to wait until a request is finished before round robining. Now, the other one is going to be the min instances, right? So in the minimum instances, this is going to be basically saying, I want to avoid cold starts as much as possible. Like, so let's say your app takes like, I don't know, 10 seconds to start and take that first request. Well, scaling to 0 is going to be painful for you if you scale to 0 quite a lot. So in that case, you may say, look, I still want to burst, meaning whenever I go over my concurrency, I still want you to spin up new instances for me. I'll take the cold start there. But you know what? It's going to be high peak time. I remember there's a few people that are big into Amazon Lambda. They'll talk about this idea that you can call Amazon ahead of time and get like your Lambdas warmed so they'll be ready to go. And I think they might actually have an official way of doing this. I think in Azure, they call them like provision functions, or like you can pre-provision them. But the way we think about that is minimum instances. So give me 3 during peak time, freeze the process, but avoid the cold start so I can be much quicker to respond, and then do bursting past that up until my max, right? So that's the way, those are the knobs you have. So concurrency, min and max instances, those are the tunables. Does that answer the question?
Yep, thanks.
I see Aaron posting a lot in the chat. Aaron, like, can you speak up? It's quite a lot to read, and like, maybe you can pick one of the questions. And you're still with us.
Oh yeah, I'm here. Sorry, I wasn't just throwing them all out there as separate questions. It was just I thought it was back and forth.
I
It's a fantastic talk. I mean, I think one of the great challenges is, you know, we sort of are in this, you know, this sort of retrograde phase with cloud native, like we go through with every kind of hot generation of technology, where everybody sort of explodes it looking for value, and now it has to sort of confront value, and now we have to sort of rearrange it around value. And you know, I've seen that over the years, whether it was DevOps or Agile or, you know, ESB, SOA in the early 2000s, BI. I mean, it's just every cycle. What I find interesting is that we have a lot of highly deconstructed programming models that really are in somewhat conflict with a lot of legacy development patterns, and having to sort of manage that as a portfolio. I don't see a lot of companies that are sort of designed to be able to handle that very well.
Yeah, I think you're right about that. When it comes to like dictating protocols and programming style, I think that's where we start to miss a lot of the value that's to be captured in this space, right? So the reason why we've been so hell-bent on containers, I've been able to package Fortran. You've seen all the things people can put in that. And as long as it can make Linux system calls, and the truth is Windows now has decent support for containers as well.
Mm-hmm.
And the concept of the container really is nothing more than a system tarball that has everything you need. So I can still unpack it, drop it on a VM, and still run it on a VM. Nothing says I have to run it on Docker or a kernel that even understands that stuff. So it's really more of a contract. So I think one thing that we've been trying to do to address the point you're making here is that if I can make clear what your application boundaries are, like you give me your Red Hat libcs that you require, you give me your Java that you require, you give me all the things you have, and if I can pick that up and move it to another VM in that same tarball, then I can probably pick it up and move it into Cloud Run. And I think that's the big advantage, is that a lot of these paradigms we see over the years, they're not reusable from decade to decade. You go all in on mainframe, good, you're stuck there. You go all in on web application servers, good, you're stuck there. I think this container thing of saying, what does it take for your application to start listening to a socket or start pulling data from somewhere? That's now the unit. No more of this like hyper specialized frameworks. And I think that's going to be key to getting us to a spot where we have standard interfaces. The same thing with health checks. Like, I don't think people understand how important it is to say, there's a way to say, if you have a health check, whether it's a socket or HTTP path, we can standardize that across all of these tools. That way we can make health checking consistent. That can survive decade over decade. So I think we need more standard interfaces, even for metrics. Then we start to have something that can be reused. So yeah, let all the platforms show up. Because the way I think about containers, I can run them on VMs, I can run them on bare metal, I can run them in Cloud Run, I can run them in Kubernetes. And it's just up to me to decide which of those compute substrates fit me the best.
Yeah, no, it's great. In a weird way, it's sort of, and I don't know if most of you are old enough, I think a few are, but it's really like the Unix wars of the late 90s. I mean, I attended this I put it in there, this really cool talk from IBM on COBOL in K8 environment. It wasn't complex, but still, at the end of the day, they were able to do a store, a COBOL store, and print, and, be able to actually call function. Now they're going to play with Jekyll Gen and be able to really, and it's not about ripping out all COBOL infrastructure, right? It's really in some ways sort of a replacement of old DB2 Connect, right? All this extra messaging layer that it's like spaghetti, right? And we're all stuck with, I mean, I find when I'm on a project, it's really not the logic that's the problem. It's all of this extra spaghetti that's wrapped around it, that you're so commingled and you just can't disentangle it. And so I think that's what can be really powerful. And I think that's sort of the ultimate value of microservices. It could be, because SOA tried to do that. It just had too heavy of a prem sort of, it was too dependent on prem-based patterns when the business world was shifting to X-prem environments. And you had to, build firewall punch throughs for secure FTP. I mean, it was just unscalable to do that.
I think compute is the last layer because of the mess that we've made. For example, look at the networking transition. We went from coax cables. I remember you just had like one of the cables off, the whole network is down.
Risky.
Right. And then you go to like the Cat5 and the various generations of that, into now what we call the internet, where most of this stuff, including Wi-Fi, is just compatible, right? So I think the TCP stack inside of the networking world and all the protocols we built on top, we're good there. And we have a fast way now of rolling out new protocols, thanks to like web browsers and semantics that we've employed. But when it came to compute, so many people are just doing effectively whatever they want, right? Like, oh, who cares about how I'm making system calls? There's 200 programming languages and libraries and backends that it's going to take time to retrofit that. And I don't know if we ever will, but if this container thing pans out, meaning put everything that's making system calls into one package, I don't care if that's DB2 or whatever, package that bad thing up, tell us what sockets and ports you need open, data in, data out, and we're going to be done with this whole different kernels and all of that. I think we're starting to see some consolidation in that space. And if that happens, I think we can turn our attention to things now, like some of those interfaces around metrics, logging, and health checking. You get that right. And then we move into another space where we start to talk about how do we route and secure traffic in a standard way. And then we might be at the network the network level of maturity.
Yeah, it's almost like we have the chance eventually in the next decade to get to sort of like engine as a service, right? Like whatever your IP really is the engine, right? It's not all this other crap that you think is IP because you had to build it, right? If everyone else if Adobe's building it for PDFs, it's not really that unique. If you're building it for your own custom package, you're just being forced to do it because none of that is compatible. But you get to that real engine, whatever that special thing is, then that's the real underlying
and
value.
the gaming consoles have really showed a good representation of that, right? Like you buy an Xbox and they all use different game engines. Xbox, it doesn't matter. I'm talking about the older versions of Xbox here, but you put the disc in, game plays. You get in a DS, you get the cartridge. It doesn't matter who the game publisher is. That platform provides all the facilities for things to just work. And I think we just got to understand that we need to start making that trade-off on the compute side of the house. Doing whatever you want is too costly long-term.
I mean, I think the biggest challenge is that when, companies, everybody really, it's not companies, just everybody is dumped BAU, run the business, right? I mean, they just want to just shovel it. And as long as the light stays on / they're not in trouble, you could do voodoo to it every day. They could care less what you're doing. And that's really dangerous long-term because you're going to look at just, the provider side has no incentive and has no skin in the game to maintain a quality of service or quality of architecture or quality of value that keeps you aligned to anything productive. I think that's the real heart of the challenge because everybody's moved all their budget over, not all of it, a lot of it, let's say 2/3 safely. And they all want to get to 80-90% to grow the business, change the business activities, all the cool stuff. And, how do you, and let's be honest, that's like 5% of your code base. You know what I mean? And so it's like 80% of your money is in 5% of your code base. 20% of your money is on 95% of your code base. What do you think is going to happen?
For most industries, I think competitors will speed that whole process up.
Yeah.
Right. We saw that in the mobile space. Apple said, I don't care about your ideas of how it should work. This is how it works. So you can get in the App Store or your competitor can get in the App Store. But this is the App Store and here's the SDK. I think what we're seeing in the natural compute space is getting a little closer to that. Either you can do it, but someone else will. So at some point, there will be a big enough forcing function. The biggest problem I've seen over the years, most large enterprises with a lot of cash, they'll look at the new thing and they'll say, I'll give you triple if you can make the new thing work the old way.
Yep.
Right? Whatever you can do to make this thing work like my old stack, I will pay triple. And this is why I think it's hard to, as a provider, ignore that when someone wants to pay even more for it to just be familiar.
Yeah, because, I think a lot of people forget a traditional global 10,000 doesn't first want to prevent disintermediation by an outside competitor. They want to prevent internal disintermediation, right? It's OCM, it's change management, it's the wars in-house because the line of business people are saying, I have a customer with a product, a contract. Why do you want to touch this? I'll go to, I'm going to die on that hill for you not touching it. And then that's where it all boils back to the provider to say, can you make this look like, 2007, whatever, like a old NetWare or whatever, SCO or something, right? It just, and that's where everybody gets in trouble, I think.
Love your questions, Aaron. Anybody else who's going to get courage to open camera?
Got 16 lovely minutes.
Last chance. So, okay, maybe while they're getting courage, like you keep mentioning health metrics, can you touch up on like stack driver, open telemetry, open sensors, like kind of crash course or something?
So when I meet all these companies, they say we're secure, require all these security things, and we have to run on-prem because something security. I was like, bro, show me the security that you're doing. And it's really no security at all, actually. It's like, oh, we got these 3 firewall rules, right? You got to go through this firewall, then you go through this firewall. But I'm like, aren't you opening the same hole in all 3? They're like, yeah, but it's 3 of them. So like the packet has to go through 3. And he's like, okay, whatever. But once you get behind most enterprise firewalls, there's usually no security at all. At all. Like literally, you can talk to any app you can, as long as you can get there between a small tuple of IP and port. And this is not the kind of security we're talking about. So why is this the case? Because it's hard. For example, if someone told you that, we talked about this little simple app that I wrote, this calculator app. So in this calculator app, if I told you that you had all of these services, right? You had an add, authentication service, multiply, subtraction, and you have an API that sits in front of it. And if I told you that you had to lock down to maximum security based on known practices, how would you go about it? And you'd be like, well, I need TLS between these, and I need a CA that can rotate the certificates. Oh, I got to think about JOT tokens. And then for metrics and all of that stuff, I got to try to figure that out as well. So when you look at this, you're like, damn, this can be pretty hard. So what we're starting to see with these patterns is that in the cloud native space, whether you're talking serverless or containers, something nice is emerging. One thing that's nice is like, what if our apps stop listening to, the public IP addresses, right? Let's say your app was to come up and just start listening on some configured port. So this is going to be like, I don't know, 8080 or something like that, but no SSL certificates, nothing. And it would expose a health check, kind of like this, right? And maybe it's going to do something real, like if there was a database, check that it can get to it. If there were dependencies, make sure that you can reach your dependencies as configured. But ideally, the stack above would only care about this, okay? And then if I know that this handler provides add, so if you call add with the right parameters, it's going to return. And if you call health, it's going to return. And this thing is going to listen with no security. Great. So then how do we bring all that stuff back? I'm going to try to do a little live demo here. May or may not work, but whatever. So I'm going to deploy kind of this stack that I've been using. I'm actually writing a guide called Mesh the Hard Way. And it's going to really explore all of these concepts, because these are the same concepts that we actually have in serverless platforms under the covers. We just don't tell you about them. But this is what's happening under the covers. And ideally, every platform will have something like this. So for example, if we deploy all those binaries and I were to make a request, let's call it a API client, right? So you get this response, right? You get a 200. There's something called Envoy. So that's a little sidecar that's in the path, but you can't see it. And I got back this answer 9. And the way this little script work is, it's just curl, right? The first thing I do is I go get a token from my auth service that's running on localhost. And I get that token back and I store it as my auth header. And then I just call this little endpoint here. Again, this is just local DNS calling this local thing. But if you looked at the code is so simple. There are no metrics, there's nothing, right? So what is actually happening? So if I go here and I look at, let's look at what's actually happening in that infrastructure. So this is a tool called Jaeger. It supports standard tracing IDs, HTTP tracing. So between all the calls, this can capture them all. And all I have to do is have a sidecar. I'm going to show you how that works in a second. But by using standard interfaces inside the infrastructure, you can see that there's 14 hops here, okay? And I went through my auth service, my API service, my add service, and also have this open policy agent, which is the standard way of doing auth-z. Can this client call this path with this auth header? If I click on that, using these standards like open tracing, you can see all the hops. Like there's this client that came through the API service, and that client was curl, and it called this endpoint. And my little sidecar, so what I have in front of this is Envoy. And this is actually what's inside of Cloud Run, and you just don't see it. But you actually have like this little proxy that sits transparently in the middle. And what this proxy is doing is saying whenever a request goes through this proxy, it's going to emit one of these trace IDs or traces to something like Zipkin or any other of these compatible HTTP tracing services. And then what you end up with is this nice kind of trace about what's going on. Once I go to the API server, you'll see that the next thing that I'm doing is I'm calling out to my authentication service. And what this is doing is validating the auth token, making sure everything is looking nice. And if it looks good, I do a little bit of policy checks. Then we eventually call the add service, which also does some additional checks, do TLS mutual auth, so we have encryption in between each component, calls out to my authz service and returns a response. But for a developer, again, a developer is still writing simple code that looks like this, right? Just have a simple handler that I register and health. No understanding of any of these other things. So what's actually happening? Well, when it comes to my policies, I'm using something like Open Policy Agent. And the way that looks is I can have these kind of policies that look a little bit like this. For example, when a request come in, my sidecar can send it to Open Policy Agent where it can get the HTTP method, the path, and I can even look up from the JWT token or some header who the requester is. I can decode that header and then use that to make policy decisions. And the way it's done in this way is it doesn't matter if I'm using serverless, containers, Express, Golang, Java, it doesn't matter. This is a dedicated component. And then the way I wire this stuff up, for example, like if I want metrics, I can use Prometheus, which is, again, compatible with some of these open standards. I can say, hey, Prometheus, for the auth service, you can get the stats from here. So in Envoy, instead of it doing /metrics, it actually presents a endpoint called stats Prometheus. But either way, when I call this endpoint, it spits out all of these stats about what's going on inside of my infrastructure. Let me see if I can show you one of them. So for example, if I were to call curl against this running sidecar proxy. So if I say curl 127.0.0.1, let's take this port here. And then let's call this. Typically, it's going to be /metrics. I can actually make it configurable. But when I call this, this is the standard Prometheus output, where it just spits out metrics that it's been collecting while the app is running. Things about HTTP latency, things about my authorization calls, et cetera, et cetera. So Stackdriver can read this. Other tools can read this. So this is starting to become an industry standard. Again, in my application code, I don't have to do very much. Now, if I did want to do something in my Express app, I can import the library and collect my own metrics and expose them. Tools like Prometheus and Stackdriver, and there are many others, Datadog, etc., can go by and scrape my app, again, using standard interfaces. The last thing I'm going to show you is my Envoy config. Now, it's massive, but this is how everything gets wired together. So if I look at Envoy, and let's go to the API, there's a lot happening here. Just like when you're running Lambda or Cloud Run, there's typically some worker that sits on the outside that's actually handling all of the traffic. So in this case, my worker is going to be listening to this particular port. It could have been 8080. It just doesn't matter. But this is going to be more like the JBoss approach. I'm going to handle a lot of functionality here outside the app. But if you look at how this is wired up, there's a lot of config here because I'm showing people how to do it by hand. But I can actually make my logs consistent so I can track data coming in and out. I can generate request IDs, and that's why you see my traces and my logs now have a consistent logging with IDs for each request. I can configure a tracing provider. This could have been Stackdriver, Zipkin, or Jaeger, what I'm using now. And Jaeger happens to be compatible with the Zipkin way of processing events. And then you have your normal routing like you would see in Nginx, routing traffic. But then you can also do cool stuff like here, where I can validate JWT tokens, and then I can extract things like the header into a new payload or a new header that's easier to parse. And then I can call other services. So what this consistency does is allow me to think about modern platforms in the future. What they will do is say, hey, imagine you see this with AWS and their app mesh. You see this with Istio inside of Kubernetes. If you're using Cloud Run, you're already using Envoy today underneath the covers. You don't even know it's there. I think in maybe the next 2 or 3 years, it's not going to be far away. You might even see something like Envoy inside of your VPC. So in every cloud, we talk about VPCs, but guess what? There's some smart thing inside of your traffic flows that's doing things like security groups and firewall rules at the VM level. Imagine if there was a smart proxy like the one I just showed you that's collecting metrics using standard interfaces, doing health checks using standard interfaces, doing TLS mutual auth and rotating certificates using standards. There are so many of these standards now. One of them is called Spiffy for identity. If you haven't checked out Spiffy, it's very simple. The way Spiffy works is, I'm going to show you what it looks like really quickly. The way Spiffy works is we try to have a universal way of identifying a workload, regardless if this is a function, a container, or a VM. And the way Spiffy works is, I'm going to show you one of my SSL certificates, X509. See if I remember this stuff. It's been a while. These are my admin days. So we want this calculator certificate. And I'm just going to show you the certificate I'm using for the API server. So we'll look at a certificate and then we'll say, I think it's text that out. All right, there we go. So I have this certificate. The way Spiffy works is I can give each of my applications a ID, and it's basically a URI. So what this says is Spiffy is the protocol, and Spiffy is basically like this workload identity that says, here's the trust domain. So this could be your company. Here's the service name, calculator, and here's the component, API. And now that this is encoded in a signed SSL certificate from a CA that I trust, I can use various tools, whether it's serverless or inside of Envoy, this proxy. What I can do there is, let me show you something that I think is pretty cool. I can say, look, anyone calling this service, let me do the add one so you can see how it goes. So the backend that the API calls, one thing I can do in the sidecar is say, look, when I'm doing TLS mutual auth, I can do something pretty neat here. I can say, look, the only things that can call me, number one, they have to be trusted by this certificate authority, okay? But then I want you to extract the ID from the certificate, and if it doesn't match API, reject it. So now we can actually have a workload identity that's universal. So like in Amazon, you use the metadata service to get your identity, and Google Cloud, you use the metadata service. These aren't portable, right? So they don't work in different services. So what Spiffy tries to do in that whole project is
Just the interesting part too. What is replacing the metadata server? I need to know.
You're back. We lost you for a second. Are you talking about? You're on mute. You're on mute. Okay.
All right, I'm back. I'm sharing my screen again. Sorry about that.
Spiffy.
All right.
Interesting.
All right, so Spiffy, right? So you look at this and say, what is the biggest challenge in cloud? Is establishing trust. So when you're in the cloud, it's really nice. Like if you're using Lambda or Google Cloud Run, you have this nice metadata service where you can go and get your identity from, right? Say, hey, give me a token that represents me and I can pass it along. And that metadata service automatically refreshes everything. But all of these services have their own unique identity, and then you would have to translate between all the providers. So what Spiffy tries to do, there's a project called Spire. And what Spire tries to do is to take this trust, and I'm going to show you their website. They have a decent site, and I think there's some diagrams there as well. So what they try to do is say, look, what we can do is we can sit on the cloud provider. Let me see if I can find one of their diagrams. We can sit on the cloud provider, and what we'll do is we'll translate for you. Let me see if I can find one. They have a diagram. So, okay, here we go. So typically what happens, let's call this an AWS VM. Now on your AWS VM, you're going to have this kind of metadata service that gives you like your certificate that you are this thing. So the way Spiffy tries to work is it can actually generate these SSL certificates for you based on a root of trust. So basically you can give it something like, hey, any VM that's running in this VPC should be allowed to run the auth service. And here's how you make sure that this thing is doing it. So a little agent will run on the VM. Okay. So this agent will say, I know how to look at the Amazon metadata service and verify that this thing is actually inside of a node pool or some identifier or a tag. There's something about this VM or this VPC that you say you trust. You trust Amazon, and I'll start from there. Then what it does is it creates a little web API, workload API. And what the workload API does, so there's also a central server here that you don't see. And that's where you do your configuration. You'll say things like, if it's a VM in Amazon in this zone or this particular IP address or has this node name, it can run these apps, okay? So then what happens is when this little agent is running on this VM, you start to establish this trust where when I start my container or when I start Envoy, Envoy actually has a way of saying, instead of me hard coding the certificates like I showed in my example, Envoy can actually talk to this agent to say, hey, I want to run the auth service. Can you give me the certificate for the auth service? Now, the agent will say, well, you are running on this VM, and the fact that you can talk to my socket means you should probably be talking to me. So then it will go and get a dynamic certificate generated just for you, private key the whole nine, and return it back to something like Envoy to use on your behalf when it's calling another dependency. The nice thing about this, I'm never giving the certificate to the app. I'm never giving it to the function like you see in Lambda. We can do this all on the outside. So this is what's happening in these managed environments under the covers. So if I were in GCP, again, it will still use the Node API. Now let's talk about on-prem. So in on-prem, you have a couple of options. One, you may not have a metadata service in your infrastructure. So what you can do is use like a certificate. You can copy an SSL certificate to a node and say, this certificate can run these workloads. So when this agent presents that certificate to the Spiffy server, it will say, oh, you have that certificate signed by a CAI trust. I'll assert based on the user's configuration that you can run these three apps. So if one of those three apps shows up, given that you have that certificate, I will also allow you to generate certificates for those workloads. Now, let's say you don't have a CA. The last thing you can do is also do something based on Linux. And you should read the documentation because it's quite good. But what you can do is you can also have a workload be validated by the Linux kernel in some ways. So what does that mean? That means you can say stuff like, hey, agent, any service or process that talks to you that has this user. So if it's running as the auth user, then if it's running under that auth user ID on this particular Unix port, that's enough for you to assert its identity. And you should also allow it to get assert for this thing. So the nice thing about this is now that we have this universal identity, you can actually start to have different providers look for Spiffy IDs. They support SSL certificates. So those agents will mint those for you and rotate them every 10 minutes or an hour. It's configurable. Or you'll have Spiffy JOT tokens. So if you're in Cloud Run having one service call another, wouldn't it be nice for each provider to be able to look inside of that token and say, oh, it's a valid token signed by a signer I trust. Let me go grab the Spiffy ID, and I will use that as the identifier to make other auth-z or IAM particular controls. So the standards are here. So one thing I've been doing is writing this stuff up. So you'll see me publish a thing called Mesh the Hard Way, talking about how Prometheus works, how Spiffy works, how Envoy works, because I bet in the next 5 years or so, these components are going to be buried in all cloud providers. And it's just going to be good to know that your apps, I think, are going to be permanently more simple going forward, because we're not doing this inside of WebLogic anymore. We're not doing this inside of Cloud Foundry anymore. We're doing these as components that can be used by all the cloud providers, even on-prem. So now we can actually leverage these things in the future.
How far is that from production?
Some people already do this. So for example, Istio already has an embedded Spiffy protocol. It already does it. So there are some companies using Envoy and Istio in production. So they're already doing it. If you're in GCP, Envoy is in production. It is our internal load balancer. If you're on AWS, AppMesh is Envoy in production. I think that's a GA product. If you're using Cloud Run, there's a little Envoy in there. So you're already using it in production. You just don't know.
Spiffy is part of Envoy.
No, so Spiffy is more of the protocol. So Spiffy is really a string that says, let's have a universal identifier.
Okay.
And it's a simple string, but we have to encode that string as something we trust. So I can't just...
It's binary encoding.
Yeah, so it's more of like, we know X509 certificates are pretty mature, but how do you know the identity of something based on a certificate, right? Do you look at the CN? Okay. Do you look at its... You know what I mean? Like, we don't have a standard. So the standard is
like OpenID connect the data about the data or something.
Exactly. So it's just one string that says there's a trust domain, example.org/server name. And if you sign it with the CA, then the certificate as it's passed around oh, I'll be looking for the Spiffy ID.
I see.
Envoy knows where to look. Other services know where to look. So now we have a nice little standard here. I think it's going to be a game changer because most of the stuff isn't hard. It's just that it's not standardized. So everybody's doing something different. And half the code we write these days is literally trying to adapt this response to this input that has to happen over here. And all we're doing is extracting this, calculating some result, and then trying to put it into another format that's compatible with the target.
So that would solve the problem calling APIs from one cloud to another.
It could, right? Because if you think about it, so it's funny, I gave a keynote at KubeCon 2 years ago where I had a container that I wrote a little tool that made that container run in Lambda by translating it just a little. And people were asking me, how did I make IAM work across the cloud providers? Well, it turns out Amazon is just standard OAuth. So what I can do is I can take a token from GCP and tell Amazon to trust it as an OAuth provider. And then when I try to authenticate to S3 using one of these Google tokens, Amazon's like, oh, sweet. That's signed by an OAuth provider that I trust. So to be honest, most IAM stacks are already OAuth. You can actually cheat by just telling each other to trust each other. This is why GitHub just works. This is why Facebook just works. No one talks about it that way because then people might actually use it that way. They rather say, do everything in this one IAM provider. But the truth is, these identities are fairly standardized already.
That's a really good tip. Thank you. That's guys, we are over time, but I like it so we can.
Kelsey, in the example you were showing us with your calc thing, there is the Envoy config and the Prometheus config. Did you have to hand roll that, or is you scaffolded by your tool set? Or
no, I hand roll everything. So let me show you exactly what we're saying here, because so Istio does this automatically. So if you're using a service mesh like Istio Linkerd, you will never go through this. Okay. But I'm one of those people who just really wants to know. So for example, you talked about my Prometheus config. So Prometheus is actually one of the easier tools because it's a pull model. You tell it what the endpoints are. And as long as they dump the standard Prometheus output, it knows how to actually do the right things in terms of what Prometheus does. So this one's a little bit easier to hand roll. But normally, like in the Kubernetes world, you would actually have a Kubernetes plugin that Prometheus supports out of the box, where it just knows how to do this, right? It can go out and find all the things and look at their annotations on the workload and automatically generate this config. But when you talk about Envoy, whenever you hear service mesh, the thing that, when I used to contribute to some of the internal tooling, like parts of Istio, one thing I recognize is that all of those high level, like YAML files that you'll see something like Istio do, they're going to end up generating a large Envoy config like this, and then sending it to Envoy over this wire. For example, when I want to talk to the ad service, I had to add in all this transport socket. What certificates do I use to talk to it? And what happens is all of those control planes like Istio, Linkerd, there's so many of these tools. What they're really doing is taking their high level kind of API or DSL, and they're just simply generating one of these. And Envoy supports what they call the XDS protocol, where this config is streamed. So whenever you make a change on the control plane, it just gets streamed down to Envoy. But yeah, I do it by hand so I can have that, mechanical empathy to know exactly how all this stuff is wired up. So now I know how to troubleshoot those tools.
Wow, cool. Michael,
all right.
Some questions before you go.
We got more.
Yeah, there was Corey Queen, multi-cloud. Yeah, that's as political as containers versus serverless.
No, we can do it. We can do it. All questions are fair game. Let's look at it. So what was the question?
Michael Travis, Corey Queen wrote a blog post. Michael, you're here with us. You can speak up. He was here. Yeah, I see you. Michael, are you there?
Is he eating ice cream?
Yeah.
You can read it out loud. Here we go.
I'm here. I just got kids in the background and stuff like that, so trying to keep it adult. Yeah, I mean, I've done some work with FaaS over the last couple of years, and was interested in that as kind of a serverless platform to basically allow you to run functions on premise, portability across multiple clouds if you stand up the infrastructure. So I kind of like that concept, but I saw a blog article from Corey Quinn where he kind of talks about kind of investing deeply in one cloud as opposed to trying to support a multitude of them. And like, I like the idea of portability, but I also understand that if you try to support everybody's cloud and use all of the technology, it's just onerous. You were talking a little bit about that previously, so I thought, what's your opinion?
Yes, I think my opinion here is that like all cloud providers do a good job of supporting TCP/IP. Right, that's good. Most cloud providers do a good job with DNS. Another bonus point. And the same thing is true of Linux, and we can go on and on. I think for us, I also agree, like trying to be portable out of the box and just doing all of this overhead for no good reason can slow things way down. So I think from a customer perspective, it's really nice when you can start using things like Envoy. So when App Mesh came out from Amazon and it was based on Envoy, I celebrated that. I was like, great, because if someone goes all in on App Mesh, they can easily move on to another platform that's Envoy based. Maybe the config API is different, but the fundamentals are the same. The feature set's going to be roughly the same. So I think for most people, whether it's open FaaS, I think when it comes to compute, I like managed compute offerings more than anything else, meaning I'd rather retrofit my app slightly than trying to run open FaaS myself. If I'm on Amazon, I'm just going to use Lambda. If I'm on GCP, I'm just going to use Cloud Function. And if you write code the way I'm writing these days, I always put in my business logic into a library, import it into the function, and then write the boilerplate that the function requires to invoke my business logic. So that way, if you told me that I have to go from Lambda to GCP's offering, guess what? I'm only going to have to mess around with that function signature, maybe 20, 30 lines max. But I see people writing these functions where their business logic is embedded in the function. And then it's always going to be a big migration cost to do that. So I would say job number one is protect yourself in terms of don't go all in where you don't have to, right? Just treat things as a library and treat any deployable signature, like a function signature, even containers. All that HTTP boilerplate should be separate from your actual business logic. You should be importing that stuff like libraries versus writing all of this nasty stuff in line. That way, if someone told you that you had to move to a different platform, your migration costs won't be so high. So that's my opinions there. But then using things like Postgres is a nice open database interface protocol. Like CockroachDB, an open source database, chose to use a native Postgres interface for their cloud native database, which is nice because now I can go from this spanner-like database by using the same Postgres driver I was using before. Now, there might be some differences, but open interfaces are the way to go, in my opinion, if you can help it. But that does not mean I would probably spend a lot of time running my own infrastructure thinking that one day I'm going to migrate and I won't have to redo all of this. You're going to have to redo it all. Trust me. Open FaaS on Amazon is going to use this particulars in terms of the metadata. If you start talking to other services, those libraries are going to have to change, right? You're not going to have access to the Amazon metadata service in another environment. So I don't know if you get all that much if you try to go common denominator.
Cool, thanks. Good feedback.
Daniel, you're muted.
Oh, you're muted there, Daniel.
No, I was asking for any more questions, or we should go to the draw. Anything else you want to share with us? Like now, elections are coming in states. Like, I like your opinions. Like, I don't know how many American friends we have here on the call, and not too many audience, but like enlighten us or educate us more while I'm searching for the winner.
I was going to say that could turn into a 4-hour debate.
What's that? Oh, yeah. So, yeah, I don't know. I mean, for companies that are not even getting value from one cloud provider, and they tell me, and I've seen it, companies are trying to build a cloud abstraction control plane first. I'm like, please stop. Like, use one, get some mileage out of that, and then you'll know when it's time to bring in another cloud provider. Just like in a data center, I knew when it was time to buy a different vendor for my hardware. Like, I might buy my Blade chassis from HP, but I might buy my, top of rack switches from Juniper. Like, that stuff will make sense when it's time. Trying to overdo that in the beginning may not be a lot of value.
Okay. Anything else? I'm ready with the names. I see 20.
That's it. Announce the winner.
Okay, so let's see. I put your name as well. You did not enter. Let me share the screen so you see what's up. There is no magic here.
Did you write this random number generator?
No, I'm everything is a service. There is a wheel of names thing, and then Google Forms provides the. Oh, there was one more. Who was late? Okay, Michael. And then I paste everything Here, I did your name. Let's see if Michael is the last or any other. Okay, Alan. So now we spin it. And you have to be here, like if you're gone, like I don't think. Unless I know how to reach you, like I know how to reach. Let's see.
Look at that.
Okay, so
We have a winner.
do we have, like I wouldn't know how to reach him. You see that the form does not include any email, nothing. So you have to be here.
Speak up or the prize is going to spin again.
Or text me in the chat your email if you're here with us. I don't see the name, so he left. We're gonna go on. Okay, 1, 2, solved. So let's say remove the name. Next. And this can be anything Manning publishes. They have some really good courses. Oh, Amaha, you were quiet.
Hey.
Amaha, you're here with us.
Yes, I am. I can't believe I won.
Yeah, too much. He was a regular. Every meetup, John and him, me and Matt was frequent guest.
So that's the trick to get people to stay on this long. It's to give away stuff. It has nothing to do with the speaker.
Kelsey, thank you very much. That was a great presentation.
Awesome. Hey, I enjoy hanging out with you all. I guess I'm going to drop here in a moment, but yeah, like there's a lot going on in the space. Thanks for spending your time with me.
Thank you so much. Like we honored and look forward to learn more from you. I will post the recording eventually when I get to it.
Really appreciate you taking the time, Kelsey. Thanks.
Awesome. Later.
Yeah, thanks, Kelsey. It was very informative.
Thank you.
It was awesome. Thanks.
See you.
Thank you, everyone.